unquote the real one. This is the final table that we have here. Again, when we think of math, we assume certainty, we assume deduction, we assume abstraction, we assume logical rigor, we assume the aims for general case theorems, right? So we want general, not specific, and we assume no hypothetical. We assume only hypothetical situations. You can imagine whatever world you want, whereas in physics it's the other way around. These points do not hold. Now, in conclusion, maybe those conclusions don't directly follow, but what I'm hoping to allude to by this conversation, by this presentation today, is the following. If we're gonna get rid of whatever is on those differences, whatever has a red X next to it, because we kind of shown this is not the case, you end up with the following table. Math and physics both are not certain. Both use deduction and induction and other forms of abductive reasoning. Both collect observations about concrete, material, physical systems. Both mathematics and physics. Of course, number 2 does not grow on a tree. Of course, you will not run into pi walking on the street. But it is nonetheless a physical object, just like we saw with the twin prime conjecture. You are looking at the list and you are verifying whether what you have in mind is the case or not. This is exactly the same thing. When I imagine it in my head, you have a picture in your, it's a mental picture, it's an imaginary picture of the list with the numbers. Okay, same thing. This is a very physical thing. Are you going to be, only a dualist can say, oh, this is not. The spirit kind of thinks in a different way. This is outside of the physical world. Fine. But as long as you're not a dualist, then the imagination of something, the picturing of something, the writing about something, the description of something, and the thing itself, of course, they're not identical. But they are both very, very physical in nature. And so when I say, oh, one of them is abstract, what is abstraction? Abstraction is only, again, with double asterisks, a connection between two physical systems. There's a physical system on the computer, and there's a physical system out there. I have a model, quote unquote, of what's out there on the computer, or on my paper, or on my tablet, or in my imagination. This model is physical. Those equations are physical. That description is physical. And the thing happening out there in the world is also physical. They are of the same exact level of reality. Both mathematics and physics, therefore, have to build, quote unquote, toys that model their claims. There's a toy that is my drawing when I'm drawing the right triangle. This is not the right triangle that Euclid describes. The right triangle that Euclid describes has lines that are infinitely thin that I cannot see. This is just a representation. It's a toy of it. And I accept it as identical, or at least similar. Why? Because I have a certain coupling. Again, I go back to that, but don't ask me about it. This is hand wavy because we haven't shown on what basis you can make that. Because you can always find the coupling, right? One-to-one correspondence you can always find an n-to-1 map, and then you can say this is the case. So on what basis do we have it? Can we just any function? This is a different discussion. But we all understand and agree, hopefully, that whenever you're building this toy model, whether it's in mathematics or physics, what you are doing is making a coupling between that and what's out there. And this is where you do your work. Physicist uses the word model, so this is a model in the sense that I just used it. Mathematicians, as I explained in the logic episode we did, it's the other way around. We say the theory is modeled by that toy. Whether you want to use it in this sense or the other sense, there's always a toy, and there's always what's out there, and there's a coupling between what you have here and what you have out there. And this is how you're doing your work. Both of them are physical. Both of them depend on your action, your observation, your analysis, your participation. And they are both not certain as a result. Now, I see Wissam in chat typing. This is not enough to prove that these two are identical. I want to address that in a minute. Whenever I want to prove, naively speaking, because I don't understand here what you want me to prove, this is a meta-theoretical proof now. I need to have a framework, a set of axioms, so that I can do my proof. So now we're gonna have to agree on those axioms, whether you agree with them or not, and then we're gonna see whether they fit whatever it is that we want to do. Naively speaking, whatever I have in mind, right, is that if you have two sets, okay, so this is mathematics and this is physics, I'm claiming that they study the same thing and they work in the same way, okay? Because whatever it is that's happening here is also happening here, and whatever it is that is not happening here is also not happening here. In my mind, this should do the trick. Now, how is it that you can tell me this is not the case? This is missing, this is misleading? By finding something that mathematics only does, okay, which physics cannot do or does not do. So is mathematics something abstract? This is how the conversation kind of happens in colloquially, right? People, oh, mathematics is abstract, so physics is real. Mathematics is induction and deduction. They count all the different and say, oh, they are different. Those basic, let's say, descriptions that people believe, we showed that each and every one of them is not the case. There is no difference as far as not only me and you, but apparently one of the leading scientists, Richard Feynman, has in mind about math and physics. Is this a proof? No, but not by no means this is a proof. But again, the requirements for a proof are not even here. What axioms and what derivation rules am I going to use to establish that those two domains are the same exact thing? I'm not sure. We can probably come up with that theoretical framework. I don't know. I don't have it in mind. This is totally not a proof. This is just negating whatever it is that people have in mind, whether they are lay people, people who are vaguely interested, or people who are absolutely in the domain. We brought those points of views and we kind of described them. So yes, absolutely. If you're waiting for an accurate, exact, deductive proof, I don't even know this is possible to provide. If you can just let me know if this connects to whatever you have in mind, or does it sound like I'm dodging the question or whatever. But I thought to address it because this is an important point. I don't think that we can do these kind of proofs until you have the theoretical framework, and I don't even think it is necessary, to be honest with you. If only my goal here today is to negate those 5 or 6 points, and if you accept with me that I have done them, I'm a very happy man. If you can find other points where they differ, please let me know, and then we can talk about them in chat. Thank you so very much for being here today. I'm done. This is the presentation entirely. So now the floor is open for your questions, your comments, other discussions you want to have. Please go ahead.